Welcome pre-calc class. Welcome students to pre-calc class on Monday the 18th. Hope you guys are doing well. Hope you had a good weekend and hope you're ready to learn some math. Let's quickly get into the lesson to save you time. If I go too fast, just pause the video. Number one, there will be a test on Monday. Now, let me point out to you that next week is Thanksgiving week, and of course that's always exciting, Thanksgiving and Christmas and all those things. Next Monday is going to be the 25th. Now, please listen to me carefully. The schedule that I sent out to your parents said that we would have a test on Monday, which we're going to, and then Tuesday, the next day after that, which would be Tuesday the 26th, we would have a video and then have off Wednesday, Thursday, Friday, Saturday, Sunday. That really was a poor decision on my part, and we've worked so hard. We're doing great. In fact, if you think about it, we take our quizzes on the weekend, and no school does that. So basically, we gain about a half a day every other week when we take our quizzes on Saturday. So let your parents know there'll be no video next week on Tuesday. There's no need to do that at all. So next Monday, or this coming Monday, you will come to my house. You will take a test. If you're not going to make it, let me know by Sunday, and then that's it. We're done until the following Monday. So enjoy your Thanksgiving break. We'll have off Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and we'll start back with a video on Monday. Let's see what that would be. Here's the schedule I sent your parents. I think that would be 25th. I'm just not sure if that'd be December 2nd maybe, but either way, you get the idea. So we'll have off all these days. Rewind the video if you need to and watch that again. And I'll go over this again every day this week. But test on Monday, that'll be our last day of class next week for Thanksgiving break. Your quizzes are due today. Now, if you don't have them done, if I don't hear from you, there will be 5 points taken off per day that it's late, okay? Integrity sheets. When you walk in my door on Monday of next week, that's it. You can't watch any more videos or do any more homework. You can, but you won't get credit for it. And you must have your integrity sheets with you, something written on paper. So please make sure you have that taken care of. And then schedule a time to come see me. Some of you have contacted me and I've gotten back with you and I have yet to hear from you, which does not make me mad. I'm not bothered by that, but I'm just saying come see me if I can help you, okay? All right, let's go ahead and get started. Grab your notebooks, grab your pencils, calculators, and let's get started. Last week, I showed you how difficult it was to take a complex number like 3 minus 2i and raise it to the 6th power. That would be like writing that parentheses 6 times, and that's really tough. But then I taught you if you change it to trig form, then the problem becomes much easier. And we looked at that last week, okay? Well, guess what? We can also do something similar with equations. Now this is pretty cool, okay? We can also do something very similar with equations. The equations that you are used to are called rectangular equations. Something like this. 2x plus 6y equals 5. And I would ask you to graph that. Or how about a quadratic equation? Y equals 2x squared minus 6x plus 3. And of course that would graph a parabola. Absolute value equations. Y equals the absolute value of x plus 3 minus 2. These are all the types of equations that you should have covered in Algebra 2. Square root equations. Square root of 2x plus 3 minus 5. Okay? All of these equations here are what we call rectangular equations. They have an x and they have a y. And that's pretty much what you're used to. Okay? So the equations that you're used to seeing, that you're used to graphing, are called rectangular equations. However, today we are going to learn how to convert rectangular equations over to polar equations, okay, and vice versa. So I'm going to teach you today how to take rectangular equations, convert them over to polar, and also take polar equations and write them in rectangular form. All right? It's actually a pretty cool procedure. Now, go ahead and write your heading down if you would. Your heading for today is Polar Equations, Lesson 7.4. The date today is the 18th, if you'd like to keep track of that. Polar Equations, Lesson 7.4, and today's the 18th. Today is the 18th. Now, before we get started, I need to show you where we get 3 formulas from. You do not need to understand this. I hope you do, but you don't need to. You will not be tested on what I'm about to show you. However, I will not be long, and it is important that you understand where these formulas come from just for your education's sake. So, you are welcome to take notes on what I'm about ready to show you, or you don't have to. That's totally up to you. Okay? But I'm going to show you where we get three formulas from, and these three formulas are very useful when it comes to converting rectangular equations to polar and polar to rectangular. Are you ready? Here we go. If I'm dealing with theta right here in my xy coordinate plane, and I have a triangle drawn here in quadrant number 1, I could say, now watch this, sine of theta equals opposite over hypotenuse, y over r. And then I could multiply both sides by r, and I would have r sine theta equals y. And do you see, pretend I have an ordered pair here, okay? And that ordered pair is x comma y. In other words, I went over how far, x, and I went up how far, y. And again, if you don't understand this, relax, it's okay. But try to understand it, okay? So, if I had this ordered pair right here, and I wanted to write it not in this ordered pair, but like we're using sine or cosine, do you see how y, this number right here, equals r sine theta? So now I know another way to write the letter y. Y equals r sine theta. That's a formula we're going to use, and that's where I got it from. Now, what if I said cosine of theta? Okay, cosine of theta is adjacent over hypotenuse, so x over r. Now we're going to multiply both sides by r, so I would have r cosine theta, r times cosine theta, and look what that equals. It equals x. So now I know another way to write x. X equals r cosine theta. Pretty cool. So here's 2 out of the 3 formulas I wanted to show you. Not that hard, and you don't have to understand this. I'm just trying to show you where we get these formulas from. Now let's talk about the hypotenuse, okay? The hypotenuse. If I said x squared, that's one of my legs, plus y squared, that's one of my legs, equals r squared, that's my hypotenuse, could I not then take the square root of both sides? So if I took the square root of this side over here, it would be x squared, the square root of x squared plus y squared equals, and now take the square root of this side, and it would be r. Look at that. So all that I did is I rewrote these values using the Pythagorean theorem, and then I took the square root of both sides. Now please don't think that the square root of x squared plus y squared is x plus y. That is totally incorrect, okay? Because you have 2 terms, you cannot take the square root of x squared plus y squared. But moving on, okay? Moving on. Now, so these are the 3 formulas I'm going to use in order to convert polar equations to rectangular and rectangular to polar. So you did not have to understand where these equations came from. However, you definitely need to know these 3 formulas. You need to know them, okay? So I'm going to clear a little space out, and you'll see why in just a second. And what I'm going to try to do here is I'm going to copy these formulas, and we're going to take them with us on all of these pages here in a second. So we'll always have them with us, okay? So there we go. And there we go. Now I'm telling you, students, these 3 formulas are paramount. You have to know these, or you cannot convert polar equations to rectangular and rectangular to polar. Okay? So with that in mind, let's continue on. I would like us to start off with this rectangular equation right here, and I would like us to convert it over to polar. Okay, so let's go ahead and get our formulas here. There's our formulas. Now, a rectangular equation has x's and y's. Now, it could have more than that or just one of those, but for now, our rectangular equations will have x's and or y's. Our polar equations are going to have r's and thetas. r's and thetas. So watch how easy this is, okay? I can make some pretty easy substitutions. Do you see how I have x squared? So where x is, I put a parentheses and then squared. And for x, what can I substitute? R cosine theta, because that's what x equals. So r cosine theta. Then bring down your plus sign and then put parentheses and then squared and then equals 25. Now what can I put for y right here? Well, obviously y equals r sine theta. So r sine theta. Now this is one term here. This is one term, so you can square the whole thing. So when you square the r, you get r squared, and when you square cosine, you get cosine squared. Plus, square the r, that's r squared, square the sine, that's going to be sine squared, equals 25. Now, I notice I have an r squared in both of these. Oh, by the way, let me pause. I mean, you've done it. You've basically written the rectangular equation. Now it's in polar form. There's no x's, there's no y's. We have r's and thetas. But even though we're done, we want to simplify. So what I notice is I can pull out an r squared. So if I pull out an r squared, I'm left with cosine squared theta plus sine squared theta. Okay? Now, think back to your trig identities. Remember, sine squared plus cosine squared, or cosine squared plus sine squared, same thing, equals 1. Remember Pythagorean identity? So now you have r squared times 1 equals 25. And r squared times 1 is just r squared. So r squared equals 25. Okay? Now, to be honest with you, you could leave the equation like this if you wanted to, or you could take the, I would prefer you take the square root of both sides and write r equals the square root of 25, which would be 5, of course. So I do prefer that you simplify as far as you can. So r squared equals 25. Take the square root of both sides. The square root of r squared is r. The square root of 25 is 5. Okay? So there we go. So you took a quadratic rectangular equation and you rewrote it. And I apologize, that's not a quadratic, that's a circular rectangular equation, and you rewrote it as a polar equation. Now I know this is brand new to you, but it really comes down to this, just substituting values in for x's and y's so that you get out r's and thetas. And that's it, and then simplify. Okay, let's try another one. Alright, here's a rectangular equation. Alright, now we're going to convert this rectangular equation over to polar. So here's an x. So 2, and then parentheses, and for x, I'm going to put r cosine theta, and then minus, and then parentheses, and then y. Well, y equals r sine theta equals 5. Okay? Now, 2 times r cosine theta would be 2r cosine theta, and negative times this would be negative r sine theta. Now, factor out an r because they both have an r, and you're left with 2 cosine theta minus sine theta equals 5. And guess what? That's as far as you can go. That's it. Nothing wrong with that. I mean, we're not trying to put a bunch of trig identities in. On the last problem, it was just so obvious. I mean, cosine squared plus sine squared, I mean, we know that equals 1. Okay, we've done that 100 times. So, but there we go. That's it. Okay, so we made a substitution for x. We made a substitution for y, and then we simplified. Usually in polar equation form, you want to factor out your r or anything else that you can factor out. You do want to try to do that. But after that, if there's no other simplifying you can do, you're finished. So there we go. Students, it's that easy. You're taking equations with x's and y's and writing them with r's and thetas. Okay? Now, let's go the opposite direction, okay? Now let's take a polar equation like r equals 4, and let's write it as in rectangular form. Okay, so here's my polar equation right here, and I'm going to write it in rectangular form. Now, if this is in polar form, notice that I have r's and thetas. Now, there's no theta in this one, but I have an r. So for r, look what I can substitute. R is the exact same thing as the square root of x squared plus y squared. So for r, I'm going to go ahead and make that substitution. Do you see it right here? R equals square root of x squared plus y squared. Now, if you did not understand this proof that I did here, don't worry about it. You don't have to understand it. Just memorize these. Just memorize them and you'll be fine, okay? That's all you have to do. So, where r is, I substitute the square root of x squared plus y squared. Now, if I have a square root and I want to get rid of the square root, you should know that you raise it to the second power. If you have a square root and you want to get rid of it, you raise it to the second power. However, you cannot raise one side of the second power without raising the other side of the second power. So, when I square a square root, I simply get what's on the inside of the square root. So x squared plus y squared equals, and 4 times 4 is 16. That's it. There's nothing else you can do. And look, you did it. This is so cool. You took a polar equation and you rewrote it, and now it has x's and y's. Now it is a rectangular equation. Okay? And sometimes when they're in polar form, they're easier to graph, and sometimes when they're in rectangular form, they're easier to graph. Okay? Every one is different. Really nothing else you could do with this, students. That's it. All right, let's take this equation here, this polar equation, and let's write it in rectangular form. So, r cosine theta. Look at that. R cosine theta. R cosine theta. What does it equal? X. So for r cosine theta, I can simply put an x and then bring down my equal 6. Now that might be the easiest problem we've done all year, okay? Alright, so you wrote a polar equation in rectangular form. Now let's try one more, okay? Let's get our formulas up here. There we go. Now, be careful here. Watch carefully, students. Now watch this, please. You could, for r right here, go ahead and put the square root of x squared plus y. You don't want to, but you could do that. But if you did that, we're still in trouble because look at this. I mean, there's really not a lot you can put in here for cosine theta and sine theta. I mean, you want to get x's and y's, and sure, we got x's and y's over here, but over here we still got theta. Okay, and if you're going to write a polar equation in rectangular form, you've got to have nothing left except just x's and y's. So it would be nice if I had some r's here with this. That'd be really helpful. So here's what I thought we would do. Just kind of watch what I do here. I said to myself, okay, if I can multiply the left side by r as long as I multiply the right side by r. Now watch what this does. Just watch how creative this is. R times r is r squared, okay? Now if I multiply this side by r, I get 2r cosine theta plus 3r cosine theta. Now for r squared, let's think about this for a second. Can I not make a substitution for r? Sure I can. So I'm going to put a parentheses and then put my squared. I bring down my 2 right here, and then in the parentheses I'm going to put the square root of x squared plus y squared. That's what r equals. So where r is, I put this and then bring down my 2. Now, do you see this r cosine theta? Well, r cosine theta equals x. Now you can see why I multiplied both sides by r. When I did that, it put an r with this term and it put an r with this term. And now I'm going to be able to make substitutions. So r cosine theta is x. So now I have 2 and then an x. And then bring down your plus sign, and then bring down your 3, and then you have r cosine theta. Well, r cosine theta, oh, did I copy this wrong? I apologize. Sorry about that, guys. This should be a sign right here. See this sign right here? That should be a sign. So r sine theta. There we go. So r sine theta equals y. So beside the 3, I put a y. Now the only thing left to do is to simplify this side over here. Look, I have a square root to the second power. In other words, I'm squaring a square root. So you're left with just what's on the inside. So x squared plus y squared equals 2x plus 3y. There you go. There's your rectangular equation. You did it. So you just took a polar equation and you wrote it in rectangular form. Okay? So that's pretty cool. Pretty cool. Now, on your homework, I would like you to do page 644, numbers 39 through 61. Check your answers in the back of the book. Do every problem. Let the homework video help you. That's what it's there for, okay, guys? Okay, I hope this has been a help to you. Call or email if you have any questions, and go ahead and work on the homework. And there's a homework help video, of course, for you to watch that will help you with this.